In as much as it is very, very important to get your calculations very correctly while you are dealing with physics, it's also very important that you get the unit correctly. Welcome back to this channel. This is Bamsters Academy. In this video, I'm going to be showing you how to write the unit of some physical quantities. And if you have not subscribed to this channel, make sure you do that before we go right fully into the video. So let's see 10 derived physical units. So I'll start with velocity. What is velocity? How do I write velocity? Velocity is the rate of change of displacement, right? So velocity is actually meters per second. You should know that velocity is meter per second. So that's how to get velocity in right way to do that. Moving on to the next physical quantity for this video is acceleration. Acceleration itself, acceleration is the rate of change of velocity increase. Okay, it is the rate of change of velocity increase. Now change in time also. If I know that velocity is meters per seconds and the unit for time is also seconds, so it's like saying the whole of velocity divided by what? Seconds. Do you get that now? So I can rewrite that as meter over s divided by what? Over seconds, right? And if I want to do that, I would have meters times over 1 over seconds, which means I have meters per second square. So the unit for acceleration is meter per second squared. That's how to write the unit for acceleration. Moving on to the third physical quantity that we want to get the unit in this video is force. Force, from the definition, we get to realize that force is given as mass times acceleration. So let me just write it this way. Force is mass times acceleration. So we can actually derive the formula or the unit from there. What is mass? Mass is kilogram, right? And acceleration, we just derive acceleration to be what? Meter per second squared. So for mass, mass will be kilogram meter per second square. So that is the SI unit for force. Okay, so let's move into the next physical quantity. This next one is momentum, right? For momentum, for us to get momentum, momentum is mass times velocity. Mass times velocity, right? If we are talking about Newton law, we'll get where this is coming from when we talk about the MV, and the likes, but we are not really concerned about that in this video. So I know that mass is kilogram, right? Mass is in kilogram and velocity is meter per second. So that means that momentum will be kilogram meter per second. That will be the unit of momentum. Okay, moving on to the next physical quantity, that's a derived physical quantity, is work. So what is work, or work done basically? So work is force times distance. So from the definition you can even get the SI unit. So work is force times distance, and remember that we said force is kilogram meter per what? Per second square. That means force times mass as acceleration, then times another distance, which is what? Which is m, right? So I have m here, I have a m here. So the SI unit for work will be kilogram meter squared per second squared. Is that okay? So that would be for work. So before I go through the next physical quantity, Just a reminder, if you have not subscribed to this channel, do well to click on the subscribe button. So the next one I want to talk about here is power. So again, what's the formula for power? Power is work done over time, right? Work done over time. So I already know that work done basically is kilogram meter squared per second squared. That's work. Now over time, which is seconds. So what do I do? So if I want to rewrite that, I'm written as kilogram meter squared, right? Then s is power of minus 2, that's still per second squared, times x power of minus 1, right? So and that is the kilogram meter squared, then per second cube. That will be the SI unit for power. Okay, so let's move on to the next one. The next one that I want to talk about is pressure. So pressure is actually force over area, and we know that force is kilogram meter, that's mass times acceleration, then over what? Meter squared. Do you get that now? So it's like saying that we are dividing m over m squared, and that's going to give me kilogram per meter per second squared. So that will be the unit for pressure. So the next one will have the next one will be talking about density, right? So for density is very interesting one that I want to talk about. Density is mass over volume. That is very simple. So for mass, what will be mass? Kilogram over m cube. So how do we write that? That is like writing kilogram per meter cube. So that is the unit for density. Moving on to the next one quickly without wasting time. That would be moment. So moment is different from momentum, right? So the SI unit for moment, you need to know the definition first. Moment is force times distance, right? Once you can know that. So what is force initially? We know that force is kilogram meter, that's mass acceleration, then times m. So as well, moment b kilogram meter squared per second squared. Just like work done, the same SI unit. So let's move to the next SI unit. The next quantity we want to consider is energy. Yeah, energy. Energy is measured in joules, right? Energy is measured in joules, which is the same thing as kilogram meter squared per second squared. And then let's consider the last one for this video and we wrap it up. The last one here is impulse. Impulse. So impulse is Ft, that's force times time. Force times time. So what is force? Kilogram meter, that is mass acceleration, then times time. So that will be kilogram meter per seconds. That will be for impulse. All right guys, thank you so much for joining on this video, and the next video will be on dimensional analysis. So if you have not subscribed to this channel, kindly do so you can see other related videos when they drop. And yes, I will see you in the next video. Thank you.